Hello. Today we will study critical point. Critical point include maximum point, minimum point, and inflection point. Okay. So we use those points to sketch the graph. Okay. Okay, shall we study critical point? Maxima and minima and inflection point. Okay, we know derivative of a function is the slope, right? So if it's the slope of the line, then the line which also the tangent line. And if the tangent go through that point, the maximum point, then all the minimum point is when the tangent line go to that point, go up or go down. So they change direction. Okay, at that point, if they don't change direction, we call that inflection point. Okay. So let me give you an example. Let's say A. Okay, example 1. Find maxima and minima of y equal x4. Okay, so y equal x4. So right here, you can say find maximum point, minimum point, or you can use maxima or minima. That's fine. Okay. So and sketch the graph. Okay. First of all, in order to find the maxima and minimum, you have to find the derivative of this function. So derivative. So you have like, so here y prime, the derivative of x4, you get 4x3. Okay, and set derivative equal 0. So if y right, set derivative equal 0 to find maxima or minima point. Okay, so y prime equal 0, equivalent with 4x cubed equal 0. So equivalent x equal 0. Okay, so when x equal 0, if you substitute here, then substitute the original function y equal x4, then y on the show equal 0. Okay, so in order to know is the maxima or the minima of the function, you get to take second derivative. Okay, y prime equal what? 12 x squared. Okay, but then and you substitute the value x equal 0 into y prime. Y prime 0 will be equal 0. Okay, if second derivative positive, then the point will be that point. This point will be minimum. Okay, if the second derivative negative, then the point will be equal maximum. In this case, because y second derivative of 0 equal 0, so we don't know if maximum or minimum. So we use the table. Okay, let me show you the way to use table. Okay, okay, x, and then the next one is y prime. Okay, and then next one y 2 prime, and then the last one is y. Okay, so from this function from negative y equal x4 from negative infinity to plus infinity. X can go from negative infinity to x to plus infinity. So x equal 0 here. So we have y prime equal 0. Okay, so you have y prime equal 0. So x equal 0. Y also equal 0. X equal 0, y2 prime equal 0 too. Okay, so when x equal 0, okay, now we set the we need to consider the sign of y prime equal 4x cubed. Okay, so we need to see y prime for 4x cubed at x0. Okay, so at x equal 0, y prime equal 0, but okay, now on the left of 0, let's see the sign of y prime. You can substitute, you can take on the left 0 here, you can take negative 1 here. Negative 1 substitute in 4x cubed, you have negative 4, so this negative is positive. Okay, so it's negative right here, it's positive right here. So on the third, on y, you go use the function going down, and this go to the point 0 and then going up. Okay, so by look at the table, you know at this point the function going down and going up, so this point must be minimum points or minima. Okay, so if in this case if you take the second derivative, if equal 0, you cannot define it at that point is the maxima or the minima, so you have to use the table. Okay, also the table is very useful. You don't you can use the table to graph the function too. Okay, so okay, so let's go. We know this. Okay, let's graph the function. X equal 0, y equal 0 is right here. The function it go down and it go up. It's a parabola. Okay. So we finished the first one. Okay. So the minimum. So this point right here, 0, 0. X equal 0, y equal 0 will be the minimum point. Okay. And this point also inflection point. Okay. The minimum point. Okay. So this one minimum point. Okay. Okay. Let's go to another example. Let me erase it. Okay, example number 2. Y equal you at x. Okay, at x equal 3x4 minus 4x cubed. Okay. Find maximum and minimum point and sketch graph. Get the function, okay? Get the graph. To find the maximum and minimum point, just take the derivative. First derivative, f prime x will be equal this derivative equal apply power rule. You get 4 times 3, 12, 12s cubed, and this one minus 12s squared. Okay, and set it equal 0. Okay, so here if you factor it 12x squared out, then you get x minus 1 equal 0. Okay, so f prime x will be equal to 12x squared times x minus 1. So this one equal 0. That means this square equal 0 and x minus 1 equal 0. So equivalent x square equal 0. Then x equal 0, x minus 1 equal 0, then x equal 1. So there are two critical points. We don't know it's a maximum point or minimum point yet. Okay. Okay, so we can use the first method to test. Okay, if you take the second derivative of this, you will have 36 x squared minus 24 x. Okay, and you replace that the value x equal 0 here. Since x equal 0 here, then you have f prime f second derivative equal. You have like, okay, let's substitute f at 0, then 0 take 30 x take 36 is 0, 0 minus 0 equal 0. So at x equal 0, the slope doesn't change. Okay, it doesn't go to negative or positive. So that point is inflection point. Okay, so when f second prime equal 0, you know that inflection point. Okay, and now let's say f is equal 1, f second prime equal 1. Okay, we plug x equal 1 to second derivative to see it's the inflection point. It's the maximum and minimum point. So we plug 1 in here. We get 36 minus 24 equal 12 greater than 0. Okay, when the second derivative of the point greater than 0, you can conclude that the local minimum point or minima point. Okay, so we already found, so inflection point, or we find critical point of this function. First of all, we got inflection point x equal 0, and also local minimum x equal 1. Okay, so we need to find the point. So that means you need to substitute x equal 0 to the original function to find y. So at point A, when x equal 0, y equal 0. When x equal 1, substitute in here, you get x equal 1, the 3 minus 4 minus 1, so y equal minus 1. Okay, so at the point 1 minus 1 is the local minimum, and the point 0, 0 is the inflection point. Okay, so now sketch the graph. Okay, to sketch the graph, we need to roll the table. This is it. Rolling the table to sketch the graph probably to me is the easiest way to sketch the graph. Okay, first you go x value. Okay, and then you go to f prime x, and then you go f second derivative x, and then finally fx. Okay. So we have x equal 0 and x equal 1. Okay. This function 3x4 minus 4x cubed, it goes from negative infinity to positive infinity. Okay, so when x equals 0, f prime s, the first derivative of this function equals 0. And x equals 1, this one equals 0. Okay. Okay, and we f it, and then we need to find the sine. We have 3 different intervals right here. We need to find the sine of from negative infinity to 0, and from 0 to 1, and 1 to plus infinity. So from x equals 0, 1, 0, 1. If you want to find the sine of f prime s right here, just take a value between these 3 intervals: negative infinity to 0, and 0 to 1, and 1 plus infinity. You can take any value. Let's say from negative infinity. Let's say from 1 to infinity. If you take 2 here, and if you substitute here, 2 to 12, 2x cubed is 8, minus 12, 2 times 4, okay, 4 times 12 is 48, 8 times 12 is 96, 96 minus 48 equals 48. It's positive, so this sign is positive. Okay, then when you go to the other interview, and the other interval, then this one equal negative. Okay, and go the other one, the try sign, positive. Okay, go and okay, one is only one is a single root of this equation. Okay, so the sign will change, but 0 is double root 12 squared, then the sign don't change. Okay, so it's go to negative right here. So the negative will be negative. Okay, and here you have negative to negative, so the arrow go down, and the positive going up. Okay, so this point right here must be, you can see it from negative to positive. So when x equals 1, so this point must be local minimum. Okay, so when x equals 1, you can substitute to original equation. So when x equals 1 right here, 3 times 1 minus 4 times 1 is minus 1. Okay, so when x equals 0, so this one equals 0. Okay, and f prime s, when x equals 0, f second prime s, okay, see f second prime equal 36x minus 24x, 36x squared minus 25. When x equals 0, this one equals 0. Okay, and also this one have two root. If you factor 12 x squared out, 12x, then you have 3x minus 2. Okay, so f second derivative have two root, 0. The first one is 0, x equals 0, and the second one is 2 over 3. 2 over 3 is right here. Okay, so this one equals 0 right here. Okay. Okay, but not important. You just need to find local minimum when x equals 0, y equals 0. That's the inflection point. When x equals 1, y equals negative 1. That's the local minimum. Okay. So let's sketch the graph. Okay, so here. Okay, we know when x equals 0, y equals 0. So the graph has to go to this point, 0, 0 here. And when x equal 1, y equal negative 1 is 1 right here. Y equal negative 1. So we know this point must be a local minimum. Okay, so we know the graph go like that. Okay, go like that, and go like that, go down, and then you go like down, and then it's going up. Okay, and at this point inflection point, so it must be go like that. Okay, you have horizontal tangent lines and go like that. Okay, so at point x0 right here. Okay, so the first part from negative infinity to 0, the graph go like this. Okay, and then this go down, and it go up. Okay, it will intercept at the point right here. We don't know what's that. So to find the x-intercept, you need to put y equal 0 in here. When x-intercept, then y equal 0. When y equal 0, then we have 2 points. So this point right here, so you have 3x4 minus 4x cubed equal 0. Okay, so the first point is 0, right here, intercept. So x equal 0, and the second point is 4 over 3. Okay, if you factor 3x cubed, and then if for 3x cubed, then you have x minus 4, 3x minus 4, and then the first one is x equal 0, and the second one x equal 4/3, so this point 4/3. Okay, so this is the graph, and this one a local minimum, when x equal negative 1 and 1, minimum. Okay, so we finished. Okay, we can stop right here because we answer on the question. So again, in this problem, the function f of x equals 3x4 minus 4x cubed. Okay, so we need to find maximum and minimum. Okay, in order to find maximum and minimum, you need to take derivative. First derivative equal 12x cubed minus 12x squared, and we set it equal 0. When this one equal 0, we factor it now, 12x squared, multiply x minus 1, set it equal 0. That means the first root is x equal 0, and the second one x equal 1. Okay, but x squared is a root, double root. Okay, so and x more, there's 2 0 here. You can we call double root because right here you can factor 12x times x. Okay, so there are 2 0, 2 0. So that's why we call double root. So x equal 0 and x equal 1. Because this one, the power cubed, and it's supposed to have 3 different roots. Okay, so that's why we have one double root, x equal 0 and x equal 1. Okay, and we test it. Okay, we test it. We know when x equal 0 and f second prime s equal 0, that's called inflection point. This one is inflection point. At inflection point, the tangent will be horizontal. Tangent equal 0. Okay, and we know with x equal 1, y equal negative 1. At this point, the function will go from negative 1, from go down and go up, so that we know it's the local minimum. Or we can based on the graph. So when you set up the table based on this graph, we can find easily how the shape of the graph go through. You can see it right here, from negative infinity go down to 0, and from 0 it's right here, it's just go flat, go straight. Okay, because it's equal 0, so it's go like that, and then go down again, and then go up again. Okay, so that's why we have that graph. With this table, you can easily grab any function using this method. Okay, so I think I'm going to stop right here. Next time we will continue to do more problem in Maxima and Minima, inflection point, so you can get used to this problem and get used to this method. Okay, this from this table you can show a lot of problem. Okay, by look at the table. Okay, so I guess today we finish today, and next time we will do more complicated problem, and that's it. Okay, so have a nice weekend and see you next video, see you next lesson. Okay, all right, thank you, goodbye.